Organic functional group in biochemistry is an important foundation. As biochemistry are dealing with chemistry in living, we are to expect that almost everything in biochemistry composed of organic substances, from carbohydrates to proteins, lipids to even DNA and RNA. Organic functional group is present. For the sake of really grasp the idea of biomolecules and to better understand how chemicals functions, let's have a review of organic functional groups. Okay, it might a bit too overwhelming. Don't worry, I got you. We will step by step unravel them again. It will not be a new now to all of us as we have studied them in the general chemistry subject. But as some memory like mine can't even remember what I have eaten last week, how would I even remember this, right? Disclaimer also, before we proceed, we will just have an overview of some of the functional groups here and not all. I only choose the functional groups that I think very important in biochemistry. So let's start. To start, organic compounds are chemical basis for life itself. As some mayayaman would choose, almost everything should be organic. And as what I have said, proteins, carbohydrates, enzyme, and hormones all are made up of organic molecules. Organic molecules or organic compounds also include natural gas. We also have petroleum, coal, gasoline, and many others like synthetic materials such as dyes, plastic, and clothing fibers. As everything in the world are made up of chemicals, there is too many of them. That is why organic and inorganic continue to be used in classifying compounds. Organic compounds are obtained from living organisms, so it is not only can be taken out from the human body or an animal body. It can also be obtained from plants, like the starch, the branches, or even the carbon we could get from burning them. Inorganic compounds, on the other hand, are obtained from mineral from earth, like the salt, water, calcium, magnesium, so on and so forth. So for today, since we are talking about the functional group, we will only focus more on organic compounds. So nearly all compounds found in living organisms are still classified as organic compounds, as are many compounds that have been synthesized in the laboratory and have never been found in a living organism. Since organic chemistry is the study of hydrocarbons, what is really hydrocarbons? So hydrocarbons, from its name implies, are combination of hydro or hydrogen and carbon only. Again, it is a combination of hydrogen and carbon only. Therefore, organic compounds not only should focus on carbon but rather of its two elements, hydrogen and carbon. It is also our hint in classifying whether the compound is an organic or inorganic. There are compounds that has carbon in them but can't be considered as organic. Example, the compound found commonly found like carbon dioxide is considered as inorganic. Yes, living organisms produce them, but so do many other natural processes. Thus, it was classified as inorganic. Other are like your sodium bicarbonate. Sodium bicarbonate, it may be or it may have a carbon in them, but they are considered inorganic. Or another example is your water. It has a hydrogen, but it is considered as inorganic. So to really consider as organic, the compound or the molecule should compose of hydrogen and carbon. Let's proceed now with the first functional group, which is alkane. Alkane is the simplest hydrocarbon that consists of four covalent bonds, which is the line, bonded with hydrogen. You have to remember that alkane are single band. So in naming your alkane, the prefix will constitute to the number of carbons followed by the ending A N E. Example, if only one carbon, that is methane. From the suffix meth or one carbon, for two carbon, the name is ethane. From suffix eth or two, and then if three, propane. If four, butane. If five, pentane. From suffix penta or five. If six, that is hexane. If seven, heptane. If eight, octane. If nine, nonane. And lastly, if 10, decane. Now you try to draw the structure of hexane. You may pause this video, get some paper, then draw hexane. So the answer is because hexane has 6 carbon atoms, and as we can see here, it has 6 carbon atoms. Therefore, hexane should look like this one. Alkane, the ene ending, are the hydrocarbons that contain double band or double covalent band between two carbon atoms. The simplest alkene is ethene. A single carbon atom can produce a double band on hydrogen. That's why the simplest alkene is ethane. Ethane molecules are completed with hydrogen atoms in both carbon atoms. So note, just like the alkanes, each carbon atom needs 4 covalent bonds. Next also to ethane is propene, then butene, pentene, hexene, and so on. So notice that the ending is ene because it is an alkane, or alkene rather. Now you try to draw 3-hexene. Again, you may pause the video as you draw the structure. The answer is the number before the name constitute to the double band location. So if you can count 1, 2, 3, that is on that third carbon atom. That's why it's called 3-hexene. Next is the alkyne, or the hydrogens with or the hydrocarbons with triple bands. So we got here the ending Y and E in its name. Next, we will proceed from simple hydrocarbons like your alkane, alkene, and alkyne to organic molecules which was grouped because of their similar structure and properties. We have here alcohols, carboxylic acid, amines, ketones, ester, and so on and so forth. First, we have here are your alcohol. So it is a hydroxyl group where hydrogen is bonded to an oxygen, which is also covalently bonded with the rest of the group. Important to note also, you have to remember the hydroxyl group. Again, hydroxyl group, which means it consists of oxygen and hydrogen. So in naming them, or before we go to the naming, your hydroxyl or the alcohol group can be attached from any of the alkane or hydrocarbons. But what R is here in our structure? So R, or other called it as R group, is any group in which carbon hydrogen is attached to the rest of the molecules. So how will you name this sample? So first, you have to count the number of carbon. And then, since it is an alcohol, or since it consists of hydroxyl, the ending is alcohol or with the suffix ol. So the name of this structure is having 4 carbon, thus it is butanol or also known as butyl alcohol. Next we have here is the alkyl halides or hydrocarbons bonded to a halogen. What is halogen? So halogen can be found in the column 7 or your periodic table, the column 7 of your periodic table. So they are your fluorine, your chlorine, bromine, iodine, and astatine or the group 7A. So to name them, you simply count the carbon, then the ending halide. Next here we have amines. Amines are organic compounds having an amino group or the NH2. It is attached somewhere in the carbon chain. They are used for dyes and for making medicines. Example of these are your methamphetamine. If you know this one, this is also or commonly known as your shabu. Methamphetamine actually not bad at all. It has a medicinal usage. However, it is not used in the market because of high addiction it could give to one using it. Methamphetamine is used to treat attention deficit hyperactivity disorder or the ADHD. Methamphetamine is also to treat obesity in people who have not lost weight with diets or other treatments. So in naming them, you simply add the ending amine. Example, if it is 4 carbon atom, it will now become butanamine. Next we have here are your aldehyde. So you might confuse it with alcohol. However, take note that aldehyde has double bond to oxygen, while alcohol does not. It is a single bond. Remember their formula are CHO also. In naming them, we simply add the word aldehyde or ending AL. Example is the molecule that has 4 carbon in which it is an aldehyde, it will now become butanal. Next we have here is ketone. One thing to take note is that it is the same with aldehyde in the sense that they have a double bond in attaching the carbon and oxygen. However, since aldehyde has a formula RCHO, we always expect aldehyde to be found at first or last carbon, while on ketone, since it has a formula RCOR, meaning it can always be found at the center of the molecule. So in naming, we simply add the ending ONE or 1. Example for the molecule having the 3 carbon atom, it will now become propanone, or we commonly know this one as acetone. Next is carboxylic acid. Carboxylic acid have the formula RCOOH or a hydroxyl group with the carbon double band oxygen. In naming, we simply put the ending OIC plus the word acid. Example, a single carbon atom simply named as methanoic acid. Or if it is a 3 carbon, it will now become propanoic acid. Next is amide or those having a carbon double band to oxygen with nitrogen in it. It's separate to amines because amines has an amino group or the NH2, while amide has only a nitrogen. Some may have it as NH only. Again, amine, the AMINE, the amine has amino group which is NH2, while your amide has the nitrogen only or NH. We call the functional group amide its formula as carboxamide. Ester sim yeah, ester has its formula RCOOR. So you always see ester on the center and thus it separates to carboxylic acid, in which you always see carboxylic acid on the first or last, similarly with your aldehyde, while ester are similarly with ketone, in which you see them on the center of the molecule. In naming your ester, we simply have the ending OATE. Example, if you have 6 carbon atom, you name it as hexanoate. Ester gives a molecule a sweet smell used for perfume and flavoring. So the next time you smell a sweet odor from a perfume, it's definitely an ester. Next we have here is your ether. I think this is the last topic for functional groups. So lastly, we have the ether. Ether has oxygen at the center of two R groups. And that's it for this video. I hope you are able to refresh your functional groups somehow and learn something out from this discussion. Till next time, ciao!